This is the TheAmpHour podcast, recorded April 15th, 2012. Episode 91, Idiographical, Interconnect, Intorsion.
Welcome to the TheAmpHour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Chris Gamble's Analog Life.
Hey, Chris, what were those weird sounds coming from your
so many weird
there?
sounds. You know, you should have heard me last night. Cut a
Do we
hole
want to
in
go
my
there?
house. No, not like that. I cut a hole in my house last night.
On purpose or by accident?
Yeah, on purpose. My weekend has been installing a new door to my kitchen.
Oh,
And
right.
I bought a Sawzall. You ever use one of those?
No, what's a Sawzall?
It's like a reciprocating saw.
Oh, right, okay. Yep.
Yeah, it's like real beefy. It's like 9 amps, and it does like 2,500 RPMs, and it can cut through anything. I was cutting through wood and insulation and everything. It was just like butter. It was awesome. It was like pure destruction.
I was watching, like I've got this new set-top box, and I tuned in all the digital channels here, and apparently they've got a new channel popped up, which looks like a home shopping channel on the free-to-air network here. And, I don't know how to get rid of the damn thing or, cancel
it. So you watched it?
Yeah, exactly. So I watched the damn thing, and apparently it's like half an hour per product by the looks of it.
Yeah, like infomercials, right?
It's like a half-hour infomercial per product on this 24-hour freaking channel. And there was this one that had this, this diamond cut, saw thing, and that cuts through everything. You can cut your birthday cake with it and then go outside and cut sheet steel and engine blocks and,
Oh, yeah, they love selling that on infomercial
freaking
channels.
Hilarious.
I think power tools are kind of a weakness of mine.
Yeah.
I can always justify it in my head. I mean, the same thing with like electronics gear. You're always like, oh yeah, I'll use that. Come on, I'll have tons of uses, and it's great when you have it. But I mean,
exactly. But then it sits there for 2 years unused.
Exactly.
Yeah.
Exactly. Yeah, I've got stuff like that on my bench too. I mean, I've got a clamp that I use it once in a while, but it's like,
Yeah, I've got tools I hardly ever use.
Right, but when you need it,
it's really
you need it.
It's nice to have it. Exactly.
Right, exactly.
Every man has to have a.
What would be what's another tool like that on your bench like that? I mean, like I guess like certain test gears like that.
Certain test gear,
like frequency counters, stuff like that. Right?
Exactly.
I mean, like,
Frequency counter. I'd rarely use it. Logic analyzer. I'd rarely. I rarely have to dig the logic analyzer out.
Right, but it's those pieces of gear that you like, man, it's just like when you're in a tight spot, nothing else really, like you wouldn't try and do that with the scope. You wouldn't try and do a logic analysis with a scope because
you can with a deep memory scope, but you're limited in the number of channels and doesn't do decoding and all that sort of nice
if it's
stuff,
not serial, you're screwed then, right? I mean, if you're trying to do like a parallel, if you're doing like a bus, you need a logic analyzer basically.
Yep, and that decodes everything, and maybe it does a state analysis instead of timing.
I love that. I found that out from a friend who showed me that at work one day. Just like the state functionality. If people have never seen that, that is just so cool. Like I know that's probably like old hat to a lot of our listeners, but to an analog guy, that's really cool. I mean, like that you can set that kind of thing up, and I think
can
they're
be
pushing
essential
that into,
too. Yeah, because timing isn't always, the duck's guts. Because if those who don't know, there's a logic analyzer can work in two different ways, or most of them. Any good logic analyzer can. One is timing analysis, and the other is state analysis. And the difference is the timing analysis works like a scope. It's
you gotta
always
scroll back
sampling.
through and
it's just
and see
continuously
everything.
sampling at a fixed interval, right? And it samples the data at that interval. And the problem with that is that if the data happens to be changing at that point, where it samples, you can either get one, you can either get a 1 or a 0. It's it's an undefined state. So you have to sample very quickly in order to get, you have to oversample in order to get your nice waveform and see the timing differences between things. But state analysis actually, instead of using the internal free-running clock, it takes the clock from your system under test. And that becomes the sample clock. So it samples the inputs based on your system clock that you're using in your system. And and that allows you to actually see what your latch is doing. Say you can actually take the say you've got a latch in your system, a parallel latch or something, and you think it's reading data wrong or something like that, then you can hook your clock line for the logic analyzer up to the clock line of that latch, and then you can see the data exactly the same as when it latches through your latch. And your logic analyzer simulates that. And that's
See, now I was thinking of something different there. So that's called state analysis. I was thinking there's actually a function, at least in some of the scopes I've used in the past, where you can set up like logical triggers. So if you're watching a bus, you program in, when it hits, 6F,
that's
right?
State triggering,
Yeah, that's what I was talking about. I think that stuff's really cool.
Oh, yeah, state. Oh,
because
then
you can do it in sequence. You could say 6. At first, it has to go 6F, then it has to go 1A, yada yada yada, and then finally take 32,000 samples or whatever it's going to be. And that's useful because
or sequence triggering. It's often called.
Exactly.
There's many
the computer knows better than you. Than when you're like looking at the bus when you're going to try and hit the button real fast. It's better to just have the internal computer do that kind of thing, right?
No, well, exactly. Yeah. And because a lot of the time you don't want to trigger on on just a single state of all the channels. You want to see, if you're doing an SPI bus, you want to trigger on a bit of serial data, So you've got to have your logic analyzer decode that in real time and go, aha, I found it, trigger, boom.
Right. Yeah.
And that's different to state analysis, which is that might be called state triggering or sequence triggering or something like that. So anyway, we had a little side thing there, which was rather interesting. Yeah. Anyway, state analysis is the other form of, and that's why logic analyzers will have two different specs. They will have, it might be a maximum of 100 meg samples per second for timing analysis mode, but state analysis mode might be less than that. So it's going to have. That's why it'll have two different specs. So go out and check out a logic analyzer and read the specs and see what it's capable of.
I've heard that logic analyzers are going the way of the dodo. Just kind of, they're not doing as well these days because you can do a lot of those are like built into scopes now. Like
and you've got in-system debugging in your microcontrollers and stuff like that.
Yeah.
Whereas back in when I was a boy, we used to have microprocessors and
circuit emulators,
and external memories and stuff like that. The systems had, a typical computer system might have 100 chips on it, on a big logic board, and to decode that, now it's all in one microcontroller or micro.
Right. And you do all the emulation off.
It's emulation and debugging, and they're very advanced these days. But back then, logic analyzers were.
Now, by the time you get to the logic analyzer these days, it's like if you've gotten that far, you're really in trouble.
Desperate.
You're thinking the silicon's wrong, or you think there might be a glitch on the something else is tugging on the line. And, yeah.
With the silicon bugs,
right, and you can't do that though with an emulator or something like that, right? You have to do that where you're actually looking at the physical bits and you're figuring out, no, that bit right there, that one's wrrong.
Well, often you can't because. If it's inside a microcontroller, it's all in there. It's not like you can get the probes right on the
internal
die.
Buses.
You're screwed. So you've got to do some clever. Your logic analyzer is your grey matter. So you've got to insert some code and do some stuff, or
you just call
up
the vendor and you just accuse them left and right until they capitulate and they say, "All right, well, we'll write an errata." And
or you go and search the errata, then you go, "Oh, damn it! I wish I would have searched this before I."
That is the worst.
Yeah, I know.
That is the worst. If people don't know what an errata is, if people out there are listening, errata is like a data. It's like an oops sheet or an oh crap sheet. The vendor puts out their first silicon. They finally release it to production. People start using it. They start filing, complaints against the silicon because I have my bus in this state and it starts, it just blows up and nothing works. And then then the chip company goes and does their analysis and they say, oh, yeah, we forgot to do that. We forgot to hook up that one line, so
oops,
don't do that.
we got the memory size wrong. Sorry about that. Oh, the serial port doesn't work as we claim. Well, Sorry about
that.
That
would be an interesting thing to know from our readers, too, or listeners, would be like the most interesting errata you've ever seen. I bet there's some doozies out there, like forgot to hook up address lines or...
Well, I've seen a microchip one where they actually got the size of the memory wrong.
Really?
Yeah.
Wow.
I can't remember which device it was. They got like 1,000 different devices, but
how much was it off though? By
it was off by half. It was like it was 8K, and it was actually programmed in the chip as 4K or something like that.
Wow!
They completely got it wrong.
Wow.
Yeah, and they said the workaround is to limit your programs to 4K. That was because they will always have workaround, right? One of these good errata sheets will have like a here's the bug and what version of silicon it applies to as well. Yeah, because that's the and I hate the ones, as an aside note, I hate the ones where they once they fix the bug, they take it off the errata sheet, right? Because they don't want to make it look bad that it's got 100 different bugs, right? But that's annoying because if you've bought some old silicon, if it's been sitting in stock for 6 months or a year, that's a real pain in the butt. So a good errata sheet will keep all the stuff there, and it'll give you a matrix table of, here's the bugs and which silicon versions they actually apply to, and you can see at a glance, that they're how they've actually fixed things. And
I wonder if in the age of systems on chip, how they now take multiple silicon die and they bond wire them all together, and then that's the actual package you buy. I mean, that's a lot of what the chips we're buying these days are, right? I wonder if there's any errata sheets where they're like, didn't include second piece of silicon, or no bond wires included.
Maybe they're internal ones, internal errata sheets.
Oh, man. That would be great.
Oh, that'd be hilarious. But so what's the weirdest one?
Yeah.
I don't know.
Well, I mean, we'll have to wait for our listeners. Hopefully our listeners have some odd errata sheets and can write in about those.
Oh, maybe like if you've worked at a semiconductor vendor, and maybe you don't anymore and you want to spill the beans. What's the biggest goof that they've done, Yeah. And is that a rite of passage if you're a silicon, design engineer or something, and do you have to screw up $100,000 new die or something as a rite of passage?
Right. Well, hopefully not. I mean, I'm sure you ease into messing those kind of big things up,
Right. Okay. Because that's the traditional rite of passage in any electronics apprenticeship. Your first job at a company, you have to blow up some expensive bit of kit. That's what you have to do.
Right. Everybody smells your first bit of blue smoke. They all gather around your cube and start clapping or whatever.
And they applaud and
clap you on the back and
That's great.
Yep.
Speaking about the old days. I drove down the coast on the weekend, which was rather nice. I actually got out of the house.
Nice.
And I picked up over 100 kilos worth of old Electronics Australia magazines.
Whoa.
Going back to the 50s when it was radio, television and hobbies.
I wish I knew how much 100 kilograms was.
Right. It's about 100 kilograms would be 220 pounds.
Okay.
Yeah.
I've been trying to do that lately. I've been trying to, it's all about rules of thumb, and there's a great XKCD about like the rules of thumb for metric versus imperial.
I haven't seen that one.
Oh, it's awesome. And then he puts in a bunch of your mom jokes in there, and it's brilliant. I'll put it in the notes. It's
excellent.
It's really good.
Let's do it, please.
But so what are these magazines? I've never heard of this, obviously, because
Electronics Australia.
Not in Australia.
No, you're not. I don't think it was big overseas. It was mainly the magazine here. It was the biggest electronics and longest running. And it's been it's the longest running electronics magazine in the world, or was. Well, it still is, but it doesn't run anymore. So I guess it still holds the record.
Yeah.
And it's been going since the 20s or something when it was Wireless World, I think.
Huh.
And it's changed names like 4 times, but technically it's still the same magazine.
When did it go kaput?
It went kaput about 9-10 years ago when they changed the name again to Eat. electronics eat. E-A-T, eat. And there were many jokes about, people said, well, you can eat me, you can eat my subscription because it was so shit. They decided to change it into a consumer electronics magazine.
Oh, the death knell.
Yes, it was at the time. And the editor at the time tried to sell it to everyone in the editorial. Oh, I think this is a really good move because, we're all going consumer and I'm sure you'll all follow us. And well, nobody did, no. They lasted about four or five editions and then they went kaput. So
yeah, that's when your ad base just runs out the other door. It's like, what do you expect is going to happen?
All of the traditional.
Yeah. That'd be like, oh, well, I've been an electrical engineer for about 20 years, actually 100 years in that case, right? Or whatever it is, 50 years. Yeah. I think I'm going to be a ballerina.
Exactly.
Can someone pay me to do this now?
And there were so many other magazines around like that. It was just ridiculous. And so it died a very short and very public death. Yeah. Because everyone actually cancelled their subscription. As soon as first edition came, everyone actually, and their money just dried up. Their funding just bang, overnight. Yeah. They couldn't keep up with the phone calls. Because back then you couldn't email, it was mostly phone calls back then. You'd call them up and say, cancel. This is shit. I don't like it. But eat. Electronics Australia Today or something. Yeah. Anyway, it changed names like 4 times. So the last time before that, it changed, I think, don't quote me about the date, but the 60s or something. It changed from Radio, Television and Hobbies, which is a bit of a mouthful, RTV and H, for those who are probably shedding a bit of a tear right now as they remember the Australian audience.
An Aussie tear, yeah.
An Australian changed to Electronics Australia because it was changing from, the hobby was changing from radio to electronics, so more, even though radio is electronics, but it was more, the hobby electronics of the time and stuff like that. Yeah. So it was going away from radio and computers were coming in, the old hobby computers and...
Yeah, they probably lost some people then too, right?
Oh, so maybe.
What's the plan for this stuff then? I mean, you're just going to have it around, read these when you get bored? Or?
Yeah, well, the plan is to get rid of the smell for starters. I'm going to have to put them all in plastic boxes. It's got that musty old magazine smell,
Yeah, I wouldn't be surprised if the bottom of the box has a mouse in it.
Yeah, we took the wife's car down there because it's the biggest and it's got the baby seat in it. So we drove down there and we put it in. And as soon as we got home, now take that shit to the office. I don't want this stinking up my car.
Yep.
Yeah. Oh, boy. So off I trundled.
She's a good sport to go with you, though.
Oh, yeah, she was. Well, it was a day out, you see. I sold it as a day out down the coast. And I got away with that, so...
That's good.
Yeah, well, it's good. Yeah, the idea is, I guess, is to... do a regular segment where I look through an old mag. I pick one out, maybe not at random. I was thinking maybe I would do maybe one from each year or something, and then, that'd give me 30 weeks of material. I could go through 30 years of magazines, and we'd see the progression in electronics.
That'd be cool. I always love looking at the old ads, too. I think that'll be the best part of that
the old ads are great. Or is that too much? Having it every year. Maybe I could do every 2 years or every 5 years or something and then see the progression. Or maybe that's too coarse. I don't know.
You'll figure it out.
Anyway, people want to give me, is that too long? Would, a 30 or 40 week going through one magazine per year be too much? Or, I don't know. Yeah. Let me know, please.
Yeah, I bet you'll find some cool old, you probably find some old Z80 stuff, and then people will be like, hey, I'm still using Z80s. And
Z80.
Yeah, Z80, sorry.
We've been through this before. You're saying it wrong.
Yeah, sure.
Yep. Bloody Yanks.
Yep.
I don't know. All right, what else have we got? Any news on today's show?
News, yes. You put some news on here.
I put some news on. Yes, the CSIRO are at it again. The Commonwealth Scientific Industrial Research Organisation here in Australia.
See, I never heard of those folks.
Well, they're the folks who invented Wi-Fi. You're welcome.
Oh, wow.
Yes, who won the big lawsuit, who beat everyone. Every company in the world pays royalties to the CSIRO for using Wi-Fi.
Wow.
Yeah, And
they must have
just won another case.
Some dough in the bank now, huh?
They're getting like hundreds of millions of dollars. Like, I think it's probably, it's going to be in the order of billions of dollars by the time they get, all the royalties flow in. And every company out there tried to steal it. They just the problem is that the standards the IEEE, the 8011 point, no, what is it?
802.11.
802.11 standard, they based it around the CSIRO patents. And they thought, because it's really good technology, and here we go, here's the standard. They didn't, and all of the companies, everyone you could possibly name, went, it's a standard. We must be allowed to use it.
Right.
Oops, no. Sorry.
Yeah.
It's
I'm kind of torn about that kind of stuff because, like, on one hand, it's like, these guys developed it, they should get paid for their work, right? And then I think, man, that's a lot of dough, Like, it's like when does that kind of? I know that.
Yeah, but it's a whole industry.
Yeah, and really, I mean,
it's chicken feed, really. Hundreds of millions or $1 billion is chicken feed compared to the entire wireless industry. You think of the entire 802.11
what I think about
wireless.
is people we know that are working on Wi-Fi, and a lot of the chip makers are probably actually paying the royalties.
Oh yeah, of course, yep.
The people that are using
the
those
chip makers
then.
and the big vendors, Hewlett Packard, Microsoft, all of them are paying royalties to.
Right.
Yep.
I just think about it affecting the little guys, and that's when it usually tugs at my heartstrings a little bit. I'm like, I don't know if I like that anymore, But at the same time, these people should get paid for the work.
I guess. And
actually, if it's at the chip level.
I watched a documentary just last week from another Australian guy. I forget the name of the company. Oh, damn it. But I'll find it, and we'll put it in the show notes. He invented this software lock technology. You know how, like, you get a product serial number, like a software serial number, and it locks it to your hard drive or / computer information, all that sort of stuff. Well, he invented that, and and he had a rock solid patent for it and everything, and then Microsoft, or did he try? I'm not sure if he tried to sue Microsoft or whatever. Anyway, there was this huge lawsuit against him and Microsoft, and he won, apparently. And Microsoft were going to pay him $300 million, right? And a huge amount of money. And then Microsoft, the lawyers, I don't know, they paid off the judges or something. Make a big bold claim there, Dave.
Perpetual,
yeah, that's smart. Anyway, a judge apparently overturned the jury. Apparently, you can do that in America.
Yes, you can.
Well, there you go. Okay,
on appeal,
and
you
then
can.
And of course, Microsoft appealed, and the judge overturned the jury decision, and he lost. And then he kept fighting for another couple of years, and apparently they settled. They finally settled. Microsoft settled,
lawyers.
And he says he effectively got more than what was originally than he won in the original suit. So there you go. Anyway, that's the little guy.
What is the story behind this, Dave? I don't get it.
This is a story of the little guy beating the corporate giant
versus
Microsoft.
like the RCA of the old days. I forget who that guy was. Remember the RCA guy?
RCA guy.
Yeah, he like basically invented television, and then fought RCA, and he went bankrupt.
Okay.
Yeah.
Right.
But
you're not talking about John Logie Baird,
he's the opposite story. What's that?
You're not talking about John Logie Baird, are you? Who invented TV? Didn't he invent TV? Well, no, some Japanese guy did first, but he's got a bad publicist, so apparently John Logie Baird got all the credit.
Yeah, maybe it's him. I'm not sure.
I don't know.
I'm not a big history guy. I don't do history real well. So
anyway, yes, that was a story of the little guy beating Microsoft, beating the big behemoth. But as you say, yeah, I'm also in two minds about that. I as much as I don't like patents, I do also recognise that they have their place, and I don't like seeing big companies rip off the little guy. In this case, it was literally a little guy in his company. He had 20 people in his company or something, and he's Australian too, which helps, and also the CSIRO.
Yes,
it was my tax dollars, right, which went into developing the Wi-Fi stuff, right? My tax dollars. You're welcome. And
Thank you,
and
Dave.
for everyone to rip it off, well,
See, I think I feel a lot better about it when I think it's going to go back into more research. Like when that happens, that's
the
great.
Thing. Yeah.
When it's lining someone's pocket,
not so good. I know.
Yeah. When like I think of like Intellectual Ventures, that Nathan Myhrvold's company, who's basically a patent. They buy patents and they defend them.
No, that's not on.
It's that kind of stuff. When that's your business model is like defending patents and then making royalties on that. That's not cool. If you're rolling back into technology. That's fine. That's great. That's the point, right? I mean, like that's
if
that is
you
the point.
develop the technology, you did all the hard yards, and you did it, and you decided to get the patent, and then somebody rips you off. That kind of sucks,
Yeah, exactly.
Yeah, unless you ripped somebody off in the first place, and you've got some ridiculous dumbass patent that's blatantly obvious. I'm not really for those, But if you do something innovative, I think you deserve to be rewarded.
Yep. Well, the other option is you can go the opposite direction, not do patents at all, and we have a bit of news about that as well.
Open it, yes.
Yeah. You can open it up, and there's a new open source hardware association that was announced.
Bingo.
Which I think is which I think is going to be an advocacy group more than anything else. They're going to be a 501c3, but that's kind of cool too.
What does that mean?
A 501c3 is a tax deductible. It's just a tax bracket thingy, so you can.
Is it a non-profit organization? Is that what it is?
Yeah, it's a non-profit.
Right,
Sorry, that's what I meant. Yeah. So I could donate money, and then I could, if I donated money to this open source hardware,
it becomes tax deductible.
Exactly.
Right. Yep. It's like a charity here. You can be you can be a tax deductible charity. So that's pretty much. Yep.
Yeah, same kind of thing here. So yeah, it's cool. I like it.
Yeah. There's some talk about it on the open source hardware list about it, Zach. Some people are unsure about what it's going to do. Are they going to, how are they going to divvy up the funding and all that sort of stuff? And there's always once money starts getting involved.
Yeah, exactly.
Yeah.
Yep. That's the same problem. I'm sure our listeners have dealt with that kind of stuff too. Like, anytime you work on a project, it's an electronics project up until the point when you start selling it, right? As soon as you start being like, well, we need to, market this and yada, 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 and I want to know how much I'm going to make off this. And, whoa, wait a second. Put on the brakes. Yeah.
Oh, boy.
The business side of stuff can always get kind of dicey. So.
Sometimes you just wish that, you didn't have to earn money. That the world was just all even. Everyone had free access to everything. Nobody had to make a living. Everyone shared everything. It was one big happy, peace-loving world. Everyone's sitting on beanbags with lava lamps and
beanbags. Yep.
Have you seen my electronics beanbags?
I have seen it. Yeah,
they're very cool. I
cool.
don't have a lava lamp yet. It's probably next.
You build your own
and a shag pile rug, right?
Yep.
That's what the wife said. The wife said you need a shag pile rug for the beanbags. Imagine if you dropped a freaking 0402 part in a shag pile rug.
No, you're never finding that.
It's bad enough on a regular flat pile carpet.
It's bad enough when it's on a regular floor. When you're on like a tile floor, you still can't find it then, Best case scenario, you have a really shiny, not dirty floor, and you can kind of look. You can get that perfect angle where you
get
the
your
light's
head right
reflecting.
down, you close one eye, stick the tongue out the right angle, and you can maybe see a glint of the component.
Right, and then if a flashlight helps sometimes too. If you have a flashlight, you can shine it over the surface, so you can see if little tiny things are casting shadows. That helps too. Little tips, for our audience. But yeah, if you got a shag rug, you're screwed.
But that's just, for me, like picking up, going to the effort to pick up an 0402 part dropped is just not worth it. It's like walking down the street and you see 5 cents and you pick it up. What's the point? It's it's 5 cents. It's not worth your effort to bend down and pick it up.
Big spender here. But if you drop in an entire drawer full of 0402s that were loose for some reason, if for some reason you store parts like that, which is not advisable,
right,
then maybe you try and pick a couple of those up.
Right,
but at that point you might as well just vacuum them all up and pick them out of the vacuum bag or something. I don't know.
Anyway, I didn't finish my news, which was the CSIRO, because we got sidetracked. Anyway, they're trialing a new wireless data systems that are over 10 gigabits per second.
Wow.
Apparently the world's fastest and most spectrally efficient. Word of the day, spectrally efficient.
Yeah.
Phrase of the day, sorry. It's 2 words. Spectrally efficient wireless links. And very cool. Like
that is cool.
It's because you can, because we're rolling out this national broadband network here, right? We're spending like $40 billion, which is like a lot of money for Australia, let me tell you.
Yeah.
And rolling out this wireless broadband, I'm not getting it until 2015 or something. Anyway, like you can't always put fibre everywhere, right? Because you've got to dig up lots of shit to lay down fibre. Right,
yeah.
Sometimes it's not practical.
Or you got to do it on the pole, right? You got to.
We don't. We don't do that here. We don't.
You don't?
Everything's underground. No, we have power overhead in old suburbs, but all new powers everything's underground now. So we don't.
That's the way to do it, man.
Yep. All of our most of our cable is underground, except if there were in the suburbs where power was underground, everything went underground. So your cable television would go underground, your cable internet, your phone, all that sort of stuff. So, yep.
I don't know if we talked about it on here, but I've seen a thing about that before where it's 10-to-1 cost difference for putting
right.
It's 10 times more expensive to put cabling underground as it is above ground.
Yep.
And so that probably is a big chunk of your 40 billion
underground,
right there.
But once you have the conduits under there, actually pulling the cables through isn't that expensive. So.
Right.
In fact, you could argue it's probably easier because then you don't have to get in the big lifts, the big cranes which go up and hook things up and stuff like that. And, you got to close roads or partially close roads and things like that.
Yeah.
So, I don't know. But, yes, that'd be right for the initial infrastructure thing. So, anyway, you can't rip up stuff like that. Right? So, they're developing this technology, once again, patented, I'm sure, to do very high-speed, broadband links and over, 10 gigabits per second with practically zero error and loss of quality. So
that's crazy. All I can think when I hear that is, how much is my wireless company going to charge for that?
Yeah, I know. And they're using the 30 gig to 300 gig band, so there's not much else competing on those bands,
nice.
And it's absolutely remarkable. And you can get apparently they're getting, for those who love the numbers, 2.4 bits per second per hertz, which is the spectral efficiency. A typical wireless link would be 0.7 bits per second per hertz. So that's for spectral efficiency. So that's the average number of bits of information per unit of time that can be transmitted per bandwidth. So per unit bandwidth or something. So there you go. Unit of the day, bits per second per hertz.
Nice.
Awesome. So that's really cool really technology.
Fast.
That's really advanced, and apparently it's very smart. If you've got like an existing band right in the middle of the band you want to use, it can just dodge around that spectrally efficiently and all that sort of stuff. It can just totally avoid that particular band. They can just program it in. I'm sure it's all a lot of DSP based. Kind of. No, they said they're using a lot of software-defined radio technology.
FPGAs do that kind of thing, and that's how a lot of even a lot of cell towers have that. Like at the base of a cell tower, a lot of times they'll have just racks and racks of FPGAs, that they can re-upload. And that is, because actually Pittsburgh in Pennsylvania, that's like a really big area for wireless networking and a lot of stuff like that. Like Verizon is one of the companies out of there. Right. And so a lot of the vendors around here in Cleveland, they always go over there, and they're comparing like our market in Cleveland because if people don't know, like vendors come in and they're very like market conscious, right? So it's like, oh, you guys are industrial. I work in the industrial market. Pittsburgh is a lot of telecom market, and they sell completely different things to people. I'll talk to a certain vendor, and they might have 10,000 chips in their catalog, but they're only going to sell me 1,000 of those, or not even that. They might only try and sell me 200 of those chips, right? Because they have segmented markets, and so I get to hear about some of the Pittsburgh stuff though, and it's just. They spend so much money on that stuff, like those wireless stations. It's just It's crazy, especially the FPGA vendors. You know, like I'm nothing. I play second fiddle to anyone in
you're
Pittsburgh,
absolutely
right?
enough. Where they're selling 10,000 chips at $2,000 a pop to these
right. Yeah,
vendors,
well, I don't know if it's that much, but it's definitely a lot. It's
Well, some of these FPGAs are a couple of $1,000s.
Yeah, that's true.
They're
huge.
Yeah,
I mean, especially
for the big
military
high end ones. I've worked on stuff where we've paid $2,000 per FPGA.
Yeah, but you're buying them in what, 1s and 2 quantities? I mean, like.
Oh yeah, true, but you know they're. No, but that's the going price, you know. And when you jump from 1 to 1,000, there's not a, you know, there's
you
not
can go down by half.
Oh yeah, half, but it's still going to be
still
expensive.
Be 1,000 then, huh?
Right?
Yeah.
No, but we were already getting the partner discount, right? Because we were a Xilinx partner and an Altera partner. You know, we're one of the strategic partners, so we were already getting the discount.
Yep.
Oh man.
There's money to be made selling stuff, but I don't think I'll ever be able to do it. You know.
Right. Too honest.
Yeah. Not even too honest. It's just I don't know if I could stomach pushing parts every day. I mean, I know some of our listeners do that, and I applaud them for it because, you know, really you gotta, you know, like I even think about how I find out about new parts, and a lot of it is through people selling me stuff. You know, like I don't have time to go out and look for my own stuff always. Sometimes I have to be like, well, what's new? What's on the taco cart today, right?
See, I've never done that.
No?
I've always done it myself. If you're going to do something right, do it yourself, you know? And component searching is one of those things. You know, I think it's a bit of a turkey shoot asking somebody, do you know of another device? I just go and search, you know?
Yeah, but
especially a component vendor.
Yeah, but if you got it like a, you know, like, I don't know, a lot of times I've worked with NDAs and stuff like that, and they'll tell you, well, we got this coming out in, 2 months yet.
Yeah, occasionally. Well, yeah, okay.
Yeah. I'm not a huge fan of that personally, but, you know, if you need it, you need it. You know, like that's basically what it comes down to. And if our listeners have never experienced that, you know, sometimes you'll talk to a vendor, and, you know, you'll talk to a big chip vendor, pick your favorite, and you'll talk to a salesperson. You say, okay, I need a new op amp that, you know, has a 100 gigahertz bandwidth, and, you know, a gain bandwidth product or something ridiculous like that, right? And oh well, we only have one that does 80 right now, but in 3 months, you know, we're sampling silicon. And
sign this bit of paper, and we can tell you about it. You know.
Well, no, that's the assumption. There is that I've already signed that bit of paper.
Oh, right, okay,
right,
got it.
And that's its own bit of hassle. So, yeah.
Oh, lovely.
And that's actually one of the complaints we've heard about the Raspberry Pi. So bring that up. We got a bit of update about that. You know, it's the same problem, is that the chip on there is a Qualcomm chip.
Yep.
And it's, you know, people, if you have this card now, right? So if you get the board, then you say, I really like this chip, I want to design with it. Well, then you have to go sign that NDA, and you have to, you know, in order to actually use it.
Do you have to sign? Really? You've got to sign the NDA to use it? Well, you can't just buy the chip?
Well, if you want to know what's actually the registers are and stuff like that.
Oh, well, the registers are, but let's say that you're using the existing software. You're leveraging the existing
Oh, yeah,
whatever.
You might be able to get away without you doing that. But, I mean, if you're really going to do development, you want to know what the registers are, right? I mean, like that.
Well, hopefully not on a platform like this. You would think that you'd want to use it at the high level. That's why you're using this sort of platform. I would like to think.
So
somebody's
you're just saying
already
you're going to
taken care of it.
copy-paste the entire layout and everything, too? I mean, like, you're just going to copy everything wholesale?
No, you can change the layout. That's what I'm talking about. If you can buy the chip and you've got access to the PCB files, right, you lay out your own custom board, but I would like to think that you wouldn't have to be dicking around with registers and stuff like that. You would use it at a higher level.
You just hang new peripherals off the
I would hang new peripherals off it, and, yep, exactly. And use the existing OS, which, it's running Linux, is it?
Yeah, it's running Debian.
Exactly.
Linux.
I would think that I'd hope you wouldn't have to dick around with registers.
Well, you'd really hope that because you don't like Linux. Yeah.
If you try to eke out, you know, each instruction for maximized performance or something like that, perhaps. But
I'm out of my league with that kind of stuff. I mean,
right.
I know that you have to sign an NDA. Or, I don't know. I've heard that you have to sign an NDA. So
to actually get the data sheet for the thing.
Right. Yeah.
So. Yep. That sucks big time.
Yep. But as an update, we had talked about that on here previously. We talked about the board, and we had aired some skepticism about it. Healthy skepticism, I think. But basically, they've passed their EMC testing, which is what the people selling it, which was Element 14 and Design Spark. Is that the other people? Who else is selling it? I don't remember.
RS Components.
RS, sorry, that's it. Yeah, and Design Spark's our community.
Ratchet Components, yep.
Yeah. So RS and Element 14 are selling it, and they mandated that so many people, not hackers and hobbyists, wanted to buy it, that they had to get testing, which I think is kind of silly, but whatever.
That was covering their ass,
Yeah, exactly.
Political bullshit.
Yep. But that's cool. So it looks like it's on track to
actually be made, because that was the big complaint. A lot of people were saying, that they've actually made it out that they'd actually made 10,000 of them and they were in stock, and they're taking pre-orders, but they weren't taking pre-orders. They were taking registration of interest.
Yeah.
They were, it was, apparently they weren't up front or something. A lot of people complained about that, didn't like the way they did it. Well, we can't please everyone.
Right.
So, yep.
But there's actually, I thought I put it in here somewhere. Andrew Back did he got an early one, and did a first experiences with the board kind of thing. Yep. It's pretty cool. He hooks up to an old CRT and does a little bit of hacking on it. So if people want to see that, it's a pretty cool video. So definitely check that out. It's on Design Spark site, so we'll link that in.
We will.
Yeah. And it's cheap. It'll be cheap hardware. It'll be cheap hardware in order to get Linux inside of something. So that'll be cool too.
I wanted to talk about home labs.
Home labs. I'm sitting in mine right now.
Excellent. I'm not.
Oh no.
I've moved mine.
Oh, that's right. Yours is external.
Yep. It is. Anyway, there was a thing on the forum about this, and somebody complained that they were they're a chemist, right? That's their
so pharmacist. Is that what I'm hearing?
No, as in a chemist with test tubes and
Yes, right.
Yeah,
right. The actual kind of chemist, not like the one we talked about last week.
Chemist.
Right.
And he was complaining that really you can't. If that's your hobby, if chemistry's your hobby, it's probably going to be very difficult to set up your own home lab. Because
without
of all the terrorism paranoia bullshit, right? You'll get.
It's not terrorism. It's all.
It's homegrown terrorism fear.
No,
right?
crystal meth. Crystal meth is the problem.
And drugs and all that sort of stuff. Well, it's both, right? So you'll ultimately get busted if you've got all these test tubes, and it's like, well, screw them. I'd say that's more incentive to me to set up your home lab, and I actually suggested that he should install cameras as well, so that when they do raid you can secretly film it and go viral on YouTube. It'd be awesome.
That's not a bad idea.
That's great. Yeah. No, screw them. Why should, if you're not doing anything illegal, if you don't have illegal intentions, well, stick it up here. I'm going to do my home lab. Thank you very much.
The real question is if electronics people would come under similar scrutiny for any reason. I can't imagine. I mean, I guess you could say the same thing as you're building bombs down there.
They do. If try and take some improvised electronics to school as a science fair project through the airport.
Oh, yeah.
Right? It's a big deal these days. It never used to be before all the terrorism bullshit, right?
Right, and when people don't understand what they're looking at, right?
Exactly.
If they see circuits
now
and they think it's
fear.
devious.
Yeah, they have this, it's an improvised, through the government's just instilled fear into everyone that, and improvised device, something with wires sticking out of it must be a bomb.
It must be.
Unbelievable.
Yeah, anyway. I remember a friend told me about that where he's talking about, electronics versus having a lithium battery in his laptop. Everybody's got laptops, and those lithium batteries are really dangerous, and it's like those just go right through on airplanes and stuff. It's like, ugh.
I know. So. It's crazy. Well, I'm not allowed to ship anything with a lithium battery in it.
Yep.
Even a tiny little CR2032.
Yep. I know. It's crazy.
Unbelievable.
I think a lot of it's perception, though. I mean, honestly, I think it is.
I know.
But what that comes down to is if you're gonna bring electronics somewhere, put it inside a box, right? Like a case, and that makes it acceptable. That's the difference. So, and,
right.
and now you have your 3D printer. We can you can print your own case for that kind of thing, right? I mean, you can.
What I'll link in is somebody posted a link to this project where it's like a headphone preamplifier. It looks very cool, right?
Yeah.
And it's encased it in clear acrylic potting compound.
Oh, I saw that.
And
yeah.
It looks so sexy. Like he folded the wire, the neat copper wires in neat lines, and all these resistors on, and it looks like an engine or something. It looks like
it kind of reminded me of like a bug, like a suspended, like an amber suspended bug.
Yeah, it was
kind of
suspended
thing.
in amber or something like that, and it just looks very cool. But would you get something like that through the airport? Right? And somebody made the comment that if you put it in a black plastic box, you probably would. Right? But because you can see the components through there, they'll go, "Oh, what's this?" And panic, and they'll, shut down the freaking airport.
Yep. Yeah, that's true. And we've talked about airports and stuff like that before on here, I think.
Yeah.
And, I think it's getting a little better, but it's no fun. I've heard. My buddy travels with electronics all the time, and he's just, he's kind of just ready for it. He has it like on the top of his, he puts it in his bag, but he knows, that he might get pulled aside for it. So he has documentation about what it is. And usually what ends up happening, is, if I recall correctly, is that he ends up explaining it to the TSA agents, and they're like, "Oh, that's pretty cool."
Right.
But, it's still a hassle. So, yeah.
Right.
No one's a fan of that stuff.
That would have to involve a TSA agent actually having a sense of humor, or B, some sort of inquisitive mind. That's
right. Yeah. That's impressive in itself, right?
Go figure.
Yeah.
Oh boy.
I think in the future, though, I don't know if this is going to be as big a deal. I mean, so I have a thing on here about plastic electronics. I saw an article on Phys.org. Oh, I hate this. I hate saying this.
Yeah, Phys.
It's phys.org, right?
Phys.org. Phys, yeah.
Right. But, that's a different one. There's a different site called Phys.org or something like that. Anyways, talking about plastic electronics. I mean, so obviously they're printed. Everybody knows that's my favorite thing in the world. But but the cool thing is actually the substrate itself is actually plastic. It's like an organic plastic, and they're using that as the semiconductor versus, like a printed metal.
Right.
And the big problem before is what they talk about in the article is before they could do it, right? But the real problem is that they were like real high impedance, like traces and so everything. Mm-hmm. So they had to use like 100 volt rails. And now they're kind of marching it down. I think they're playing with the chemistries and everything like that. It's kind of the collision of chemistry and electronics, and they're playing with those chemistries. And now they're getting it down into like the sub 10 volts, which is still not realistic for much of anything, right?
Oh, well, you start getting into the 9-volt battery category, though.
Yeah, that's true. But I mean, if you're actually looking at doing any kind of like processing or anything like that, I mean, in terms of like power and, so you need to drop your voltage. It's that whole power equation. So the switching speeds and your switching frequency and the voltages you use, that's what ultimately determines it, right?
Yeah.
So, and capacitances too, right?
So these things are really...
They're still out there, yeah.
Very early stage. We're talking, probably 20, 30 years away from becoming mainstream. Sorry, dude.
No, that's okay. Stupid Alan Yates. Oh, man, that guy.
What? What's wrong with Alan? What's he done
Alan
this time?
is a former guest of the TheAmpHour. If people haven't heard, he's a brilliant hacker. We've talked about him a bunch of times on here before.
We'll have to have him on the show.
Oh, maybe. But I can tell you right here, he talks about printing JFETs, right? And I'm like, oh, my God, he's using his 3D printer. And then she posted a picture, and it's like a JFET symbol. It's probably
it's a plastic toy.
I know. It totally was. It looked like it was like a disc he was making to throw. And I got my hopes up and dashed again. I don't think he did it for me. I think he was just doing it to be whimsical, and it worked. They're cute. They're cute little toys, but... Yeah, I know. I'm such a sucker.
Oh, boy.
Oh, boy.
There you go, folks. Chris going to be a sucker for anything.
You
just email him or tweet
April
something
Fools
and
anytime,
copy him
right?
on it, and he'll believe it.
Exactly.
Yep. Oh, boy. I don't know.
Yep.
I wanted to talk about connectors.
Connectors. What about
We
them?
don't talk about connectors much on here.
They're really not that sexy of an electronics thing, but
they're not,
really
but they're
important. I know, and I've actually been doing connector stuff too, so that's good timing.
Yeah. Molex have these new crimp terminals. Well, they're part of their MiniFit range, and they've got a mating cycle life of 1,500 insertions at 13 amps, which is pretty cool actually for a crimp connector. So it just reminded me, because I've done quite a bit of engineering on this over the decades, and in terms of rating connectors and testing their usability life and all that sort of thing. And it's not something that most people give thought to, but connectors do actually have, a rating life, a number of mating cycles, and it can be as low as 10. Or 5, right?
Yep. I think some HDMI connectors are rated that low. I've seen some for that. Like really, because they don't put any gold on it or anything like that. It's just... Well,
one of the reasons you moved from the USB Mini B to the Micro, right? They moved from Mini to Micro. Is if you look at the data sheet for a Mini connector, it's only rated to like 10 or 20 cycles or something. It's not much.
Oh.
Or maybe even 100 cycles at most, right? Which if you think about USB stuff... right, you're always plugging and unplugging those. Yeah. So that's not many. So they went to the micro connector, one of the reasons being that it had in the order of thousands of mate cycle lives. Yeah. So that was, apart from making it smaller and, as well, but one of the major things was to increase the rating life, because the Mini always sucked at that.
So the insertions are actually, like, that's all based on just like friction, right? That's just a physical thing of rubbing two pieces of metal together.
Angle as well, because how do you define? I've been involved in this as well. How do you define mating cycle life? Is it human insertions or is it machine insertions? Like, and do they are the boards aligned? Like, if you've got two boards and you want to, if you've got a board to board interconnect, say, and you've got like 3 different connectors spread over the board, then they're sort of self-aligning kind of thing. But it depends on how they were soldered onto the board too. One may be slightly offset to the other one, and then there's a bit of compression at that angle and this angle. And then if you're talking about human insertions like a USB plug, well, what angle does it go in at? How much force does it go in with? And, it's very complex to
it's kind of where mechanical
specify this.
hits electrical, right? I mean, it's the real world, right? So it's where...
Oh, yeah. Yeah, it's a big deal. So there's obviously these Molex crimp terminals. They've rated for 1,500. I haven't actually checked the data sheet to see if there's any clause there, whether or not that's like only valid for one, or whether or not it's valid for like a 100-way connector or something like that. That's all self-aligning almost, and but there can be a big difference between how you actually characterize it.
Yeah,
it might do 1,500 insertions, but it might do 5,000 machine insertions, or vice versa.
Interesting. So, that's a big part of cost of a project too. That's another important thing, is that like cost on connectors can eat you up immediately, and that can actually start to determine how many boards you have in a project, right? So if you're like, oh well, I'll just put in, I figure I'm going to have a processor board, and then maybe a board for doing analog or analog input stuff, and then I'll have a power supply board. And it's like, well, you can do that, but maybe you should put it all on one board. And I don't want to buy a bigger board, or I can't fit it. It's like, well, maybe you should make it fit, because you might have to put up to six connectors on there, right? And that can
they could be $5 each. For a good quality, like 30-way board-to-board interconnect or something.
Yeah.
These things aren't 10 cents each.
Yeah, you talk about volume discounts. I mean, I've seen some ridiculous volume discounts on connectors. Because they just charge you so much in the low quantities, and then they just drop off a cliff when you get to high quantities, because that's what they're used to, right?
For the cheap ones, but if you're talking about good Molex brand or something like that, board-to-board interconnects, even when you get a 10,000 of them or 100,000,
maybe our relative cost assumptions are different, but I mean, I've seen some pretty big discounts from volume.
Well, but there is a base cost, especially if you use high quality ones with really thick gold plating, because that's a lot of the mating life cycles will be determined by the quality and the hardness of the gold plating on them, for example.
And gold right now is a really big deal, because if people don't know, gold prices right now are like $1,800 an ounce or something ridiculous like that.
And if you've got a 100-way connector with really thick high quality gold
30 microinches of gold doesn't sound like much until you coat, a couple, a couple square meters with it, right? Exactly. If you hover all your connectors, and it's like, holy crap.
That's why these connectors aren't cheap, I'm telling you.
Right, yep. Exactly.
And it's a big deal. And especially in a test environment, because I've had one of my big backgrounds is in a production test environment, right? I've designed countless bits of production test gear, and you've got test cables you've got to plug in and out. And if you're making thousands of products, these cables have to last for thousands of insertions, or you have to put a plan in place. Like I've had to do research studies and do reports and recommendations for how long this particular test cable is going to last. Okay, we have to actually replace it strictly after 500 mating cycles or something like that.
I bet you miss those days, don't you? Testing cables and everything. That just sounds like such awesome fun work.
Such awesome engineering fun, yeah.
Ugh, that sounds terrible.
It's part of real engineering, right?
I know, it is.
If you get a job in actually producing production stuff, this stuff is super important.
Yeah, this is where the rubber hits the road, to use that horrible phrase. But it's like this is real stuff. I mean, like, and like especially when you get into high power stuff too. I mean, like you can imagine even if people can imagine a couple mating cycles of gold and just a little bit of gold rubbing off, or even more of the connector rubbing off. Yep. But say you're pumping 10 amps or 100 amps. I've seen 100 amp connectors recently that are just these huge things. Yep. And where if you go from 10 milliohms to 20 milliohms, you could really start to affect stuff, right? I mean, if you're pumping 100 amps, right? So you start to, and then your connector melts down, right? It's like, that really affects things. So.
I know. And then the cost, that hidden cost involved in intermittent issues, like if your contact's starting to play up, and then you think there's a fault in your product, but it's actually your test interconnects, and that wastes
you desolder every chip on the board and you replace them.
That's why we would think, like these test cables we used to use, they would cost thousands of dollars a pop, right?
Really?
Yeah,
wow.
Thousands of bucks, because they use these special connectors which hook up to our product, and our product uses special connectors, and they're $1,000 for each connector, right? Yeah. And we'd have to make made-in test cables. So that made-in test cables would cost $2,000 or $3,000, right?
Holy
and
crap.
we would strictly replace those after every 100 cycles or something like that.
Jeez.
And the cost was massive, but if you didn't do it, the cost was even greater when you had to troubleshoot your product and you stop your production line, you stopped a day's worth of production, which is worth $200,000, right?
Yep.
There's
the cost
deal.
of that, and then the cost of you, which is a lot of people say, "Oh, well, you're free." It's like, well, yeah, but you could have been Dave Jones could have been off working on something else, or designing a new product. And engineers aren't cheap, man. Like that is a huge part of any production or engineering budget is people. That's the crazy thing. It's like almost all people. You think, oh, well, this is a $50,000 scope I'm buying. Well, who cares? We've got Bob.
And then there's the other hidden costs, like pissing off your customer because your production line's delayed.
Oh, cost of quality, yeah.
That can be a big deal.
Yes. Yeah, an important buzzword.
Right.
Yep. Yeah, I used to have a thing posted on my wall that said, people forget about low cost much sooner than they forget about bad quality, or something to that effect.
Yeah, something to that effect, yes.
Yeah.
Yep.
And then I went and bought cheap stuff all over again,
That's right.
I'm as big a culprit as anyone. I'm a very big cheapskate, and I always say, oh, why didn't I pay for quality? And then I do it the next day.
Because you thought you could get away with it. The lure of being able to beat the system,
Oh, yeah.
And get away with it is very strong.
Yep. The other thing about connectors, having good connectors is good, but I tell you, I hate shopping for them. I cannot stand trying to find them. Oh,
yep.
That's the one
totally
thing
agree.
where I still use a paper catalog, because trying to go online, just not worth it. Because you know what you want in your head. You're like, oh, I want it to be about this shape, and I want it to have however many the pins you can do with a parametric search. But I was complaining about parametric searches on Twitter the other day, a couple weeks ago, and that's actually what it was. It was about connectors, because I want to be able to look at something and say, I want that, but not that, and I want it to,
It's based on the look, really. That will be your first pass thing. Is that probably it's one of the few things in electronics where you would basically do the look first. Maybe a case would be, a similar sort of thing. If you're shopping for a case for your product, you're going to look. You want to see a list of pictures, not a list of. Right. Not a list of parameters or something like that.
You might do that with like a transformer, right? Where you're willing to get, you want it to be a certain shape, and you want your certain, core shape or something like that too. But there's not a lot of the stuff like that in electronics because usually it's the actual specs of stuff before you start looking.
Sometimes you'll do a package. Okay, I want a TO220 package, so I'm going to limit.
Right.
But let's ignore that. And I totally agree. You're thinking, okay, I've got two boards. I want to join them together. I want a low profile board-to-board connector. So you want, you can't do that searching by specs often. You've got to just look at the photos.
Yep. Yeah, and that's where I'm just flipping through pages, just kind of like idly flipping through, and then boom, I see it. I'm like, oh, that's what I want right there. I know that.
Exactly.
That's the one I want. So.
And then you look into the detail and find that it has some obscure thing which rules it out, and you go, bastard.
Yep, and then you keep flipping. You go back to flipping. Yep.
I know. And often you won't find the perfect connector you're after. It's always a compromise, I find.
Oh, yeah.
I think rarely have I found the perfect connector in every possible way. Well, you can go out
and tell someone what you want. You could draw it up and get it
custom
made.
Yeah, I've been there, done that.
$1,000 connector right there, right?
That's why the connectors in our products cost thousands of dollars. They're custom made,
Yep.
And oh boy.
Oh,
there are companies that will do that though. There are companies.
Oh yeah, a lot of companies will.
Even
usually it's volume based. If it's not volume based, then it's money based.
Yep. Well, it'll be money. Yeah, like often we would only want a few thousand connectors, right? We wouldn't want 100,000 of these things, right? We want a few thousand to start off with, and maybe we might crack the 10,000.
Right.
But they're usually big, right? They'll be a big, huge thing, and they're very expensive, and they cost a couple of $1,000s each. And 1,000 times 1,000 is $1 million, right? So even if it's 1,000 connectors, that's a reasonable amount of business.
Yep.
Right there.
Yeah, so, a lot of it comes down to that stuff we were talking about last week with injection molds and just getting those molds made and all the design work behind that and the machining and yada, 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 yada. Yep. A lot of the mechanical side of things. So.
And then you've got to specify it. Yeah, then you've got to characterize the connector yourself. That's an issue with making your own connectors. Getting your own connectors made is,
Yeah, a lot of people don't think about that as, those graphs on data sheets, those aren't free.
No,
someone had to do those.
Yeah, and I've had to build test jigs to actually test the number of insertions and measure the contact resistance after X number of insertions.
Terrible.
And all, automated jigs, which sit there and, and doing 1,000 insertions.
Yep.
Oh,
yikes.
It can be fun because they're fun to watch. You know, especially when they fail and the pins all get bent and it just grinds and that's great fun.
What's that word? Schadenfreude or no? What's the word?
Idea.
It's a German word.
But sometimes you sit there just praying for it to fail. Come on, you bastard! Come on, fail! I want to see it bend those pins. It's good fun. Anyway.
Yep.
That's real engineering.
Yes, it is. Should we do a chip of the week?
I think better because our amp hour's up.
Yeah, we're running out the back, huh? This is. So I got two on here, but I think the one actually I kind of grabbed off of Nice Chips, which is a Reddit thread, and I think the chip of the week helped that along, but I don't think we're the only reason that it started. Anyways, it's a big.
No, it's not. Who I think it is again.
Who?
The manufacturer.
Oh, yeah. Come on, man.
No.
They're
chip of the week all the time.
All right, I'll go back to the other one then. All right, fine.
Oh, no.
Well.
No, let's do it. Come on.
All right, fine. It's linear technology again. Those guys. I know.
No. Gas.
Yeah. This is a cool product, though. I think so. It's a cool part. I think some of our listeners would like it. Basically, it's a clamp. It's a surge stopper. So what you do is you put this thing, you can float it above a voltage, right? So say you got like a 100-volt rail. So you put a MOSFET in line with the 100-volt rail. I don't know if it can do 100 volts, actually. Oh, yeah, 100 volts, wide operating range. It can do up to 500 volts. So you say you got a 100-volt rail, you put this thing floating on that rail, and then you put a MOSFET in line, and then basically if it sees a surge on the other side of the MOSFET, it'll say, okay, that's too much. You can set how much it is, how much overage you want. So you say, I want every 10 volts over, I want you to trip, and then it'll pinch that that MOSFET shut, and then you're protected against surges.
And can it clamp it to a programmable voltage? Is it?
I think it can, yeah.
Because it's showing an example here of a 28-volt rail clamping to 43. Well, that might be undesirable, you know.
Right. Well, you program it with there's a resistor chain there, so you program it with that, and then that'll actually, tell you which voltage you want it to clamp to based on some ratio and internal reference, yada yada yada. Right. But yeah, it's pretty cool. I think it's. And then there's also like a cooldown thing. So if you wanted to say, if it goes over by X amount, you figure your MOSFET's probably all hot, so you give it some time to cool down before it turns back on if you want. And
yep.
I like it. But, I think our listeners would like it.
Okay, so it raises the question: how do you protect the surge protector?
You mean from like a
surge,
super huge kind of thing?
Is it by definition it's self? It doesn't need a surge stopper because it's designed to handle surges, right?
Right. Well, if it's above, if it's above 500 volts, I think it probably would blow up. I mean, everything has a characteristic impedance, right? I mean, you can't just say, you can go to 1,000,000 volts, right? I mean, if you hit something with lightning, it's probably going to blow up, right?
Well, there are ways to protect things from lightning.
Yeah, I mean, and they'd probably tell you the same thing here. Put a diode in front of it, or
put a big fat transorb on the front or something. Yeah.
Yeah, something like that. Yeah. Right, so you could do something like that, but I mean, if you're doing that, you're probably not using a little chip for that kind of thing, right? I mean, you're probably using transorbs.
Why would you use this chip, this solution, which needs an external MOSFET over, say like a transorb or something like that, which are designed to suppress surges?
I have to imagine because it's programmable, and so if you had like a rail,
you can buy different spec'd transorbs for different voltages.
Yeah, but the difference here would be this pinches it off, right? So you don't draw any current at that point versus a transorb where it just eats all the extra current, right?
Well, that's the whole idea. It has to absorb the energy.
No, but this doesn't. It turns off the MOSFET. It just then the MOSFET determines how much it can. So if you have a 500 volt MOSFET in there, you can just stand off the 500 volts. That's the idea. I would imagine if you had like a shared rail, with like a bunch of stuff, and then you knew that the rail had a possibility of going from 30 up to 60, even though you didn't want it to.
Okay, got it.
Because of like a inductive spike or something like that, then this kind of thing would be good.
So it's more of a failure stopper, really, than a surge stopper, I think.
Yeah, that's probably
if you know what I'm getting at.
Yeah, I think you're right. Because surge has a certain connotation
that you don't know how big it's going to be, right? But sometimes when you're designing a system, right, if there's say you're designing a 240 volt powered electronic, powered directly from the 240 volts, right? If something fails, then like if something in your DC to DC converter fails, then you may get the full mains input on your circuitry, and that may be the worst case. So you'll know what the worst case voltage is in your failure scenario.
Yeah.
So whereas surge, it's open ended. You don't know what that. That's why I'm saying you would probably have to protect this surge protector against even bigger surges.
Well, you always put a transorb behind it, right? I mean, something
exactly.
like that.
Well, that's the thing. That's what I'm getting at. So, I think they should probably rename this to a failure stopper.
Failure stopper. Yeah.
But then people are searching for surges, right? It's keyword.
Right, yeah. This is the problem they're trying to solve is, surges. Yeah. It's crazy tiny, too, this chip. It's DFNs.
I don't trust it, then. I don't trust a surge protector that's in a DFN, a 2 millimeter
Well, the
DFN
FET's doing
package.
all the work, man.
Don't trust it. No, I don't. No, still don't trust it. No, not getting that
Dave
warm
wants to
fuzzy
flip
I need.
a relay. He wants one of those big metal switches and
a big
Young
knife
Frankenstein.
switch.
Yeah.
Oh boy.
Yep.
I don't trust tiny shit.
Well,
it doesn't instill confidence.
Yep. It's not a TO 247 or something like that. You don't trust it.
No. Sometimes it's not about the specs, it's about confidence.
Right. Yeah. And perception in that case, right?
Perception of confidence, yep.
Right.
Absolutely.
Right. Must be able to take all the heat. It's huge.
Exactly. It must be. It's grunty. Oh, yeah.
We sold this Dave guy a huge part. We made it out of cake batter, but yeah, he loved it. it's never gonna work. It couldn't stand off 3 volts, but it's huge.
It looks the part, yeah.
We made it on a silly putty.
Oh boy, we're way over time.
We should go. People could find us on Twitter, on Facebook, on Google+, on email at TheAmpHour@gmail.com. And one more thing, people should, if you're just listening on the website, we think it's a great idea to subscribe to the podcast link in order to automatically download this thing every week in your favorite podcast listener, such as Google Listen or Podcatcher or whatever you use. So thought I'd throw that out there this week.
Because then we can more accurately find out how many people listen to this crap.
Yeah. All right, more crap to come next week. We'll talk to you then, Dave.
Bye.